Once we have built our baseline model, the next step is to do improvements on the baseline model to build advanced models. So in this video, we will see how are some of the methods by which we can build advanced or improved models on top of the available baseline model which we have just built in our previous video for our fashion MNIST data set. So this is the same code from my previous video, but here I am making a certain change to prepare or to see whether I can build an advanced model on my available baseline model. Now there are many ways that we can explore to improve our baseline model, and the one method is to add padding. So adding padding to a convolutional operation can often result in a better model performance, as now we have more of the input image pixel are given an opportunity to participate and contribute in the output, right? So as we have discussed in our detailed discussions on convolutional network, I have mentioned that there are two types of padding. One which is called as valid convolution, and second which is called as the same convolution. So as you can see, I have in the model architecture, that is in this function, the only change I have made here is I have now added a padding and said that it is a same padding. So what a same padding means is, it means my padding, an amount to be padded P, will be equal to F minus 1 by 2, which is in our case equal to, so F is the size of our filter, which is, as you can see, I have selected a 3x3 filter, so my filter size is 3, minus 1 divided by 2, which is of course 2 by 2, that is equal to 1. That means I have decided to change my architecture with padding is equal to 1. That means every image in my data set will be now padded by a degree of 1, or will be given a 1 layer of padding. So this is one method to improve your model. Now again, I am not rerunning it. When you can try that for yourself. You can rerun this code with padding is equal to same and see if your model's performance is actually increasing. If so, at what percentage it is increasing. Now another method of improving your model is to actually increase the number of filters, right? So adding more filters can often improve the performance of the model, as it provides more opportunity to extract more simple features from your input image. And this especially becomes very significant when you are using a small filter like 3x3. So again, in this example, this is a new example. So again, this is the same code. The only difference is in this particular line, where now rather than the 32 filters, so in my previous example I had used 32 filters, but now I am using a number of filters to be 64, and then as like in the previous example, padding is equal to same. Right? So this is one method by which you can improve the performance of your model. Now, depending upon your data structure and depending upon the architecture as a whole, it is not always necessary that these could lead to any improvement. Sometimes what happens is that adding this change could actually decrease the performance of your model by some account, right? So but this is always some methods which you can try to see if adding these changes will help you come up with a better performing model.